Good afternoon to you all. So now we can start discussion. So can you hear me? Can you hear me?
Yes, sir.
I have that the screen also audible. So we can go ahead. I think we have discussed 3 lectures right now. Under those discussions, extruded. The last week we have discussed extruded eye parts, single screw extruders, and all forming like these things, and not other non-Newtonian and Newtonian fluids. So, and also we have discussed about the assignment as well. I asked you that I will share the assignment guide. So I will share it as soon as possible with you. lectures තුනක් කතා කරා මම හිතන්නේ අද හතරවෙනි එක තියෙන්නේ. එතකොට දැන් ඔයගොල්ලෝ මේ හොඳ අයිඩියා එකක් ඇති එක්ස්ට්‍රූෂන් කියන්නේ මොකක්ද කියලා. මොකක්ද අපි එකකින් කරන්නේ වගේ එක්ස්ට්‍රූඩ් එකක් අඳුර ගන්න ඒ වගේ දේවල්. I suppose that you are familiar with those things. So we can go ahead. Today I am going to start the lecture 4. It's about some technical details about extrusion. අපි මේක ගිය සතියේ කතා කරා. So if it is what happened with the resistance. So when we close the die, or if it is a very if it is a die with very thin pore, which means a very little opening, so we can identify it as a high resistance die. අපේ ඩයි එකේ තියෙන සිදුර ඕපනින් එක ඉතා චූටි නම් ඔයගොල්ලෝ දන්නවා ඒක රෙසිස්ටන්ස් එක වැඩි. Or if it is a closed die, the resistance it is maximum. So as a result of that, you know automatically what happens, the pressure will increase. නේද? ඩයි එක ක්ලෝස් වුණාම හරි ඉතා පොඩි සිදුරක් ඕපනින් එකක් තිබ්බොත් එතන ප්‍රෙෂර් එක වැඩි වෙනවා. but ඩයි එක ඕපන් වුණොත් ලොකු සිදුරක් තිබ්බොත් ඒකේ Q වැඩි. Q means the output, and pressure also. Pressure low, very low pressure. ඔයගොල්ලෝ දන්නා දැන් ගෙදරත් අපි ඉන්දියාව පහදනකොට එහෙම පොඩි සිදුරක් දිනක් ගත්තොත් ටිකක් හයියෙන් push කරන්න ඕනේ. That is the thing, right? And there is a point called operating point. So operating point is actually a unique one for a particular extruder. It means based on the extruder, the characteristics and engineering, fabrication, and the design, and also the die shape. So operating point is actually a unique standard for a particular extruder, right? So what you need to understand is, so these things easily you can understand, and there is a term called operating point, right? So it is actually based on the extruder characteristics. Right. So this is very important again. If you have any question, please ask. So this is actually discussion, so you can ask your questions, or you can text those questions via this chat box. Right. Then when it comes to extruder, you know there is a flow, right? When we start the extruder, right, the screw is start moving, then initially there is a drag flow. So you know, when we are mixing raw materials, initially there is a drag flow. That is not a completed flow. මේ අපි මුලින්ම raw materials දානකොට extruder barrel එක fill වෙන්නේ නැහැ. එතකොට මොකද වෙන්නේ? pressure එක ඇදගෙන raw materials ටික ඇදගෙන ඉස්සරහට යනවා. But with the time, you know, it convert into a solid bed. ටිකක් වෙලා යනකොට ඒක solid bed එකක් වඩ convert වෙනවා as a result of the raw materials, right? So we have discussed those things in the last discussion. So today we are going to discuss with the net flow and drag flow, and also there are different types of flows and flow rates. Those are very critical, right? Here you can see three terms: net flow, forward flow or drag flow, or backward flow, pressure flow. Right? Forward flow means it means to the side of the moving side. Moving side. It means the extruder the extruder shaft moving side. Backward means opposite side. So we call it as pressure flow. Right? So these things are very important. And here you can see a term leakage flow, right? Leakage flow. In this picture, the first picture, you can see the pressure flow and the drag flow. But what are the differences in between these two forces, pressure flow and drag flow? Based on its side dimensions, and so you can understand the pressure flow and drag flow are opposite. And leakage flow is also there, right? We will discuss. And in this equation, you can see output equals drag flow minus, within brackets, pressure flow plus leakage flow, right? What is the meaning of that equation? So in this picture, right hand side picture, you can see drag flow to this direction from right to left. It means in this end, you can see the die, and here is the motor side. So the extrude also moving from right to left according to this picture. So මේ පින්තූරය අනුව මේක ඩයි එක තියෙන මේ පැත්තේ ඔයගොල්ලෝ පේනවා ඩයි එක. මේ පැත්තට තමයි drag තියෙන්නේ. Drag flow එක කියන්නේ raw materials then raw materials are moving from right to left. So drag flow is there. You can see the arrows and the side. But pressure flow. Pressure flow. Pressure flow එක වැඩ කරන්නේ ඒකේ අනිත් පැත්තට. Right? I think you can easily understand it. Right? You know the pressure is very high in this area as a result of the high resistance. So therefore we are using very hard materials for to develop dies to maintain the pressure. So you know the pressure is very high in this area, right? So as a result of that pressure, then there is a pressure flow to the opposite direction. මේ පැත්තට flow එක වෙනකොට මේ ඇතුලින් pressure flow එක නිසා backward flow එකක් යනවා. Right? එතකොට net flow rate එක කියන්නේ forward flow නැත්නම් drag flow එකකින් අඩු කරන්න ඕන pressure flow එක. Right? ඒක simple maths. It's general knowledge, you can understand. Therefore, you can see the net flow rate of this extruder is around 150. So it means there is a backward flow and forward flow. When we increase this backward flow, you know what happened to the net flow rate? It will reduce. The backward flow net flow rate. So therefore, if it is a good extruder, efficient one, we have to reduce the backward flow. We can't increase the drag flow. So you know that is the specific design machine for a particular design. So it is there is a standard drag flow is there. So we can control backward flow. So backward flow එක අඩු කර ගන්න තරමට තමයි machine එකේ efficiency එක වැඩි වෙන්නේ. Right? මම හිතන්නේ ඒක තේරුණා ඔයගොල්ලන්ට. So I am not going to explain it further, right? So screw channel depth, deeper screw channel depth, pressure flow and net flow. So we are going to discuss the effect of these factors on net flow rate, right? How to affect these factors on net flow rate. Screw channel depth. What is the meaning of screw channel depth? You can see what happened when we increase the screw channel depth. And deeper screw channel, it means with highest value. Screw channel depth එක වැඩි කරොත් මොකද වෙන්නේ? Pressure flow එක වැඩි කරොත් මොකද වෙන්නේ? Right? Net flow එකට කියන එකයි බලන්නේ. ඒ වගේම ඔයගොල්ලෝ මෙතන පේන picture එකක්. Here you can see a grooved barrel. Groove එකක් එක්ක තියෙන barrel එකක්. Right? What is the purpose of using grooved barrels? Anybody can guess? I have a grooved barrel like use करा. For what? Avoid or to control this pressure flow. ඔයගොල්ලෝ දන්නවා එතකොට අපිට මේ pressure flow එක අඩු කරගන්න පුළුවන්. මේ groove එකේ හින්දා. Right? ඒක නිසා තමයි අපි screw pen එකටත් අර පොඩි thread එකක් groove එකක් තියෙන්නේ. ඒක ඉක්මනට ඒ කියන්නේ backward එක අඩු කරගන්න ඉක්මනට easily we can fix it. Right? So there is option. So we can use grooved barrel to avoid or to control backward flow. ඒක නිසා high pressure use කරන extruders වල බොහෝ විට ඔයගොල්ලන්ට දැක ගන්න පුළුවන් groove කරපු barrel එකක්. ඒ කියන්නේ මේක ඇතුලේ groove එකක් තියෙනවා. මේ වගේ. or any design එක වෙනස් වෙන්න පුළුවන්. එහෙම groove එකක් තියෙනවා. එතකොට if it is a smooth surface, smooth barrel surface, so it means you can get an idea about the pressure inside the extruder. So barrel එක surface එක smooth නම් ඒකේ pressure එක ගැන idea එකක් ගන්න කොහොමද ගන්න පුළුවන්? Give me an answer. So PSA and BMDS. No. Miss ne, sorry. එතකොට barrel එකේ surface smooth නම් ඒකේ pressure එක ගැන idea එකක් ගන්න පුළුවන් නේ කොහොමද ගන්න? සම්බිලව
pressure එක අඩුයි.
pressure එක අඩුයි. Right, that's good. And number 8, FPT 19B1 8. So Mrs. Polko මොකක්ද answer?
pressure එක අඩු වෙනස.
Right. pressure එක අඩු වෙන්න ඕන නේද? එතකොට pressure එක අඩු හැම එකේම හැබැයි surface එක smooth නැහැ, but you can get an idea. මේවා technical details ඔයගොල්ලන්ට හදිස්සියවත් barrel එක smooth නම් පොඩි idea එකක් ගන්න පුළුවන් මේක inside pressure එක ටිකක් විතර අඩු එකක් කියලා. Right. Then we can discuss with the die resistance. So we have discussed these things last week as well. Die pressure and output. You know, with high die pressure, output is lower. Die pressure එක වැඩි වෙනකොට output එක අඩු වෙනවා. එතකොට die එකේ resistance එක වැඩි නම් when we increase the die resistance, it means a closed die over die with a small opening. So the resistance is very high. එතකොට මොකද වෙන්නේ? Output is comparatively lower than the low resistance die and pressure is comparatively higher than the low resistance die. Right? You can understand that one. And in this diagram, this graph, you can see die pressure, and the x-axis you can see the die pressure, and y-axis the quantity, the amount released, or batch quantity per second, right? pressure එකත් එක්ක කොහොමද අපේ output එක vary වෙන්නේ මේ different factors එක කියලා මේකේ බලා ගන්න පුළුවන්. Right? First, we can discuss high resistant and low resistant. So you're familiar with high resistant, mean P value is higher, low resistance, P value is lower, right? That's familiar with, right? And Q is higher in low R, Q is lower in higher. ඒක ඔයගොල්ලෝ දන්නවා. එතකොට deep screw එකක් පාවිච්චි කරොත්. What is the meaning of deep screw? With higher channel depths නේද? screw එකේ deep depth එක වැඩි වෙනවා කියන්නේ channel depth එක වැඩි වෙනවා. ඒ කියන්නේ මේ flight height එක comparatively higher. එහෙම වුණොත් මොකද වෙන්නේ? What happens to the pressure? Comparatively shallow screw එකක් කියන්නේ ඒකේ flight height the height එක අඩුයි. ඒතකොට ගෙනියන්න පුළුවන් quantity එකත් අඩුයි. Right? So if it is a deep screw, you can see the quantity is higher. It means the efficiency is higher. It means the output is higher, but pressure is lower. If it is a screw, if it is a shallow screw, contain a extruder, so the Q is lower than the first one. එතකොට screw එකේ depth එක වැඩි නම් එයාගේ pressure එක අඩු වෙනවා. එයාගේ output එක screw එකේ depth එක වැඩි නම් output එක වැඩි pressure එක අඩුයි. screw එකේ depth එක අඩු නම් pressure එක වැඩි output එක අඩුයි. එතකොට ඕගොල්ලන්ට extruder එකේ එක part එකෙන් part එක දැක්කොත් now you can guess how we can use this extruder, right? So if you are going to use if you are going to develop any food product, a plant food product, so you can select or even you can imagine the flight height and the surface of the barrel and the screw characteristics. Likewise, you can the pressure, shear like things you can determine, right? ඔගොල්ලෝ ඒව තමයි දැනගන්න ඕන, right? So කඩේට ගිහිල්ලා මේ මනිස් ගන්නවා වගේ products ගන්න බෑ. So you have to decide which parameters you need before purchasing. So I'm going to develop soya meat or any tip-like product or any meat-based product. So you know what the pressure should be, whether it is a low pressure or high pressure, or the retention time, if it is a cooked one or ready to eat or ready to cook one. So based on the application and the product, all these characters should be discussed before purchasing, right? I think it's clear. Now we can classify. We can classify extruders into different categories. So you know there are some classifications. So we have discussed in first two lectures based on whether it is a single screw extruder or if it is sometimes might be a double screw extruder or twin screw extruder. So likewise we have classified. But today I am also going to discuss with a different classification method. So based on the process or equipment parameters. Process or equipment parameters might be we can use for dry or wet materials based on our based on the parameters. And screw shape. By using the screw shape, we can further categorize or classify extruders. Solid screws or segmented, we will discuss. And degree of shear, high shear extruders, low shear extruders, medium shear extruders, we can classify. And heat source. So it means sometimes if it is a hot extruder or cold extruder. So here we have used temperature as the classification criteria. However, the main classification of single screw extruders based on degree of shear and also the heat source. So that is the main thing, but we have different classification methods. So I'm not going to explain it, right? Okay. So then based on the configurations, there are different methods they have used. There are different configurations they have used. Increasing root diameter. Now you know what is root diameter, right? So I'm not going to explain this is root diameter, so I'm not going to explain, right? So there are some screw extruders which is having what do you call the screw with increasing diameters. It means from the left side or starting end, the diameter might be 3 centimeter. At the end, diameter might be 5 centimeters, right? It means increasing root diameter. What is root diameter? So you know, right? Decreasing pitch, but constant root diameter. What is a pitch? You know. So from left to right, pitch has been decreased, but root diameter remains as a constant. Then third one, constant root diameter. Root diameter here also constant. It is remaining a constant. So and screw pitch. Here screw pitch and RD also constant, but decreasing barrel diameter. What is the barrel diameter? So you know what is the barrel and its diameter, right? And constant root diameter, constant screw pitch, but restrictive pockets in constant diameter barrel, right? Restrictive pockets. So we will discuss what are the restrictive pockets and combinations of above. So we can identify different extruders based on the application. They have developed different types of extruders by changing or by altering its configurations. So එතකොට මෙන්න මේ දේවල් වෙනස් කළා අපේ application එක අනුව අපිට extruders ගන්න පුළුවන්. එතකොට මේ පේනවා ඔයගොල්ලන්ට screw එක වෙනස් කරපු හැටි කොහොමද වෙනස් කරලා තියෙන්නේ මෙතන constant නෑ solid එකක් නෙවෙයි තියෙන්නේ different characteristics here you can see. The first one, increasing root diameter නේද root diameter එක වැඩි වෙලා තියෙනවා. එතකොට මේකේ constant root diameter එකක් තියෙනවා but flights වෙනස්. මෙතනත් flights වෙනස්. මෙතනත් එහෙම. මෙතන you can see increasing root diameter. All these things are increasing. This is constant. And flight depth. From here you can see this, we call it as a single conical screw. If it is a double conical, so decreasing flight depth, right? From here to here you can see flight depth has been decreased. Double conical screws increase the output rate while retaining the barrel length and the axial angle. And if it is active conical, flight depth has been increased, right? එතකොට අපේ application එක අනුව අපිට මේ screw එක විවිධ ආකාරයකට හදා ගන්න පුළුවන්, design කර ගන්න පුළුවන්, right? It is very important to have a unique screw for a particular extruder. තේරුණාද? මම හිතනවා ඔයගොල්ලෝ තේරුණා කියලා. ඒතර අපි හදන්න යන ප්‍රොඩක්ට් එක අනුව කොච්චර දේවල් අපි සැලකිලිමත් වෙන්න ඕනද එක්ස්ට්‍රූඩ් එකක් ගන්න කලින්. සමහර අය කරන්නේ එක්ස්ට්‍රූඩ් එක කලින්ම ගෙනල්ලා ප්‍රොඩක්ට් එක හදන්න යනවා. ඒක වැරදි. ඊට පස්සේ සමහරවිට අපිට පුළුවන් මේ ස්ක්‍රූ එක මාරු කරන්න. There are some extruders we can change the screw based on our applications. There are different types of screws they have. ඒතර එකම extruder එකේ අපිට මේක මාරු කරන්න පුළුවන් නම් අපිට different products හදන්න පුළුවන්. Right? You can see some other examples also. Constant pitch increase in root diameter. You can see root diameter has been increased. Here root diameter remains constant, but what happened to the diameter decreased. Barrel diameter decrease වෙලා තියෙනවා. Here different shapes and types you can see here, and bow shapes also you can see, right? Smooth bow එකක්. ඒ කියන්නේ barrel එක අපි අර කලින් කතා කරා වගේ groove වෙලා නැහැ. නේ? සාමාන්‍ය කියන්නේ low pressure වලට සාමාන්‍ය අපි use කරන එකක්. ඒතර මේකේ සාමාන්‍යයෙන් pressure flow එකක් තියෙන්න පුළුවන්. And longitudinal grooves, different types of grooves and spiral grooves. අපි කලින් කතා කරන්නේ groove එකක් තියෙනවා කියලා මෙතන. මෙන්න මේක. Right? Different types of grooves are available based on our requirement. right? ඒතර සාමාන්‍යයෙන් වැඩිපුරම තියෙන spiral groove එක ඔයගොල්ලෝ දැකලා තියෙන්නේ spiral groove එක අපේ screw පෑනේ එහෙම තියෙන්නේ. It's actually a spiral groove and longitudinal grooves are also available. And based on the shear, degree of shear, you know what is shear? It is very important in extrusion. And cold forming and high pressure forming extruders. So based on the shear, moisture content around 30 to 40%, moderate conditioning moisture percentage, low shear, smooth barrel surface, deep flight, low speed, right? So cold forming, low shear, pressure එක අඩුයි, smooth surface එකක් තියෙන්නේ, speed එක අඩුයි, deep flight තියෙන්නේ. Flight එක deep වුණාම ඔයගොල්ලෝ දන්නවා pressure එක අඩුයි. Not used for thermoplastic extrusion. Here you can see some examples. Pasta cookies, pasta dough like products we use. To develop this type of products, we use cold forming extruders. If it is a cold forming extruder, temperature also low, shear also low. If it is a high pressure forming extruder, here low shear, grooved barrels, high pressure. If it is high pressure, so we have to use grooved barrel, right? We have to use pre-gelatinized flask and example potato pellet, right? Third generation flask, right? So you can read and understand these things. And low shear cooking extruders. So these things are very important. Please remember a few examples. Then you can, when you go to the market, please select some extruded food products and imagine the type of extruder they have used. ඔයගොල්ලෝ කඩේට ගියාම extruder product එකක් අරගෙන ටිප් ගොඩක් තියෙනවනේ. බලන්න මේක මොකෙන්ද හදලා තියෙන්නේ. මොන වගේ extruder එකක්ද? low shear එකක්ද? collet එකක්ද? high pressure එකක්ද? low temperature එකක්ද? grooved barrelද තියෙන්නේ? මොන වගේ තියෙන්නේ කියලා හිතන්න පුළුවන්. එතකොට සාමාන්‍ය collet කියන්නේ high pressure එකක්. high pressure එකක්. එතකොට grooved barrels තියෙන්න ඕනේ. Right? Multiple shallow flights are there. So low moisture, so call it expanded food products. We have to use low moisture, right? And high temperature. So you have to read these things. I am not going to read all these things available in these slides. So you have to read and understand. So there are different types of extruders are available based on its application and requirement, right? And you can see some examples, and you can collect some more examples, even some names like tippy like names. There are different types of snacks. So go to the market and understand who is the producer, who is the manufacturer, and where they manufacture these products in Sri Lanka, whether it's exported one or local one, and the price and the raw materials they have used. So all these things are important. You can do a self-study, right? And further, we can classify product moisture content. You know, if it is a high shear one, like collect extruders, we have to use low moisture content, right? For low shear, we use for pasta, so moisture is high. And all these parameters you can see here. What happened to the channel depth, right? Channel depth. So you can see. And barrel temperature, maximum barrel temperature you can see. So, and this slide is for you. This is a home work, right? So you can go to the market and identify some extruded food products and classify those things into different categories based on the extruder. So you have to determine, you have to imagine the extruder they have used, type of the extruder, and shear and pressure and flight height, whether it is a grooved barrel or a smooth one. So you have to imagine all these things and write at least 3-4 examples, right? The next time I will check. So you have to write all these things. Okay. Then how to calculate the solid flow rate? It means the flow rate of extruder. You can see an example here. And sorry, you can see the equation here. MS means solid flow rate, and these things are important. Kilograms per second. එතකොට කොහොමද අපි solid flow rate එක calculate කරන්නේ කියන එක තමයි මේකේ තියෙන්නේ. Solid flow rate එක ඔයගොල්ලෝ දන්නවා extruder එක ඇතුලේ යන solid flow rate එක. Right? එතකොට මේක බොහොම ලේසි දෙයක්. හැම වෙලෙම standards use කරන්න ඕනේ kilograms, seconds ඒ වගේ. And rho means solid bed density and channel height, channel width, number of parallel flights, barrel velocity, solid conveying angle, screw helix angle, right? එතකොට ඔයගොල්ලෝ මේ හැමදේම දන්නවා දැන්. එතකොට මේ අගයන් ටික මෙතනට ආදේශ කරලා හොයාගන්න පුළුවන්. I will give you an example so you can practice it as a home work, right? එතකොට මේ ඔයගොල්ලෝ පුරුදු. එතකොට efficiency එක වැඩි කරන්න නම් give me few answers. So we are going to increase the efficiency of this particular extruder. So how to change these factors, right? So increasing efficiency means increasing the flow rate. So we have to increase the flow rate. So these are the responsible factors. So right, channel height, channel width. So we can increase these. Right? එතන මේ දේවල් ගොඩක්ම සමපාත වෙන දේවල්. ඒතර කොහොමද මේක වැඩි කරගන්නේ කියලා ඔයගොල්ලන්ට හිතන්න පුළුවන්. මේ ගාණ හදද්දි. Right? එතන මේක ගාණක් තියෙනවා. A low shear extruder used in the plastic manufacturing company has designed as follows: channel height, channel width, number of parallel flights, solid conveying angle. All these things are there. I have given all the things, all the factors. Also, they use water and wheat flour as a major raw material, and the average door density is calculated as 100,260 kilograms per square meter, cubic meter. Calculate the net product weight of the first batch. Net products weight of the first batch produced within 9 to 10 hours a day, while the barrel velocity maintained at 10. So එතන මෙතන ඔයගොල්ලන්ට පේනවා හැමදේම මම දීලා තියෙනවා. ඒතර ස්ටෑන්ඩඩ් යූස් කරන්න ඕනේ. ඒතර මම අහලා තියෙන ප්‍රශ්නේ තමයි ෆස්ට් බැච් එකේ කියන්නේ පළවෙනි පැයේදී කොහොමද කොච්චර ටිකක් එනවද කියලා. ඒතර මේ ඉක්වේෂන් එකේ අහලා තියෙන්නේ අපි කියලා තියෙන්නේ kilograms per second. But my question is kilograms per hour. Right? So you have to read the question carefully, and the equation is there and calculation method also there. So please solve the question yourself and then check your answer with the correct one, right? Then we are moving towards twin screw extruders. අපි ඒතර දැන් single screw extruders ගැන කතා කරා ගොඩක් දේවල්. I hope that you know some basic parts, basic things about single screw extruders and how to use it, how to select it, what are the important parameters, how to do some calculations, some engineering calculations, how to calculate its velocity, right? What are the responsible factors for the velocity, flow rate, and what is the purpose of using grooved barrels and smooth surfaces and the materials used to develop. So all these things I think you're familiar with, right? So now we can move to other parts, but please read these things and do the homework. So today you have 2 homeworks to do the calculation and go to the market and collect, and you can just see the products and read the label and collect some information and just imagine the type of extruder they have used and processing conditions, right? Pressure, temperature, at least whether it is a high pressure, low pressure, or medium pressure, you can imagine. So හරියට මොගොල්ලෝ කියන්න බෑ දැන් ටිපි ටිප් එකක් කඩෙන් ගත්තොත් ඒක මොන වගේ එක්ස්ට්‍රූඩර් එකක්ද පාවිච්චි කරන්න කියලා ඔයගොල්ලෝ දන්නවා. ඒතර ඒක ප්‍රෙෂර් එක කොහොම එකක්ද? මොයිස්චර් එක කොච්චර සාමාන්‍ය 10ද 15ද කියන්න බෑ. ඒතර low moisture ද ගන්න අපි high moisture ද ගන්න. ඒ වගේ ඔයගොල්ලෝ දන්නවා. So you can write it down. Right? When it comes to twin screw extruders, මෙතන තියෙන major වෙනස්කම් කීපයක් තියෙන එකක් තමයි මෙතන screws දෙකක් තියෙනවා. But in single screw extruders, you know, there is only one screw inside the barrel. And the transport mechanism here, it is positive displacement. But in single screw extruders, you can remember transport mechanism is shear force. So raw material සැදගෙන ආවේ අපි shear force එකෙන්. නේ? ඔයගොල්ලෝ මතක ඇති. අපි screw දෙකක් පාවිච්චි කරන අවස්ථාවක raw material සැදගෙන ඉන්නේ positive displacement කියන method එකේ. We will discuss what is positive displacement. Right? Typically, the internal barrel surface is smooth. Internal barrel surface is smooth. ඒ කියන්නේ එතනදී වෙන pressure flow එක නවත්තන වෙන method එකක් they have used නේද? Temperature difference, heat distribution is comparatively lower than single screw extruders. සාමාන්‍යයෙන් අපි use කරන temperature එක අඩුයි. Temperature difference එක අඩුයි කියන්නේ temperature එකත් අඩුයි. එතකොට අපි සාමාන්‍යයෙන් food industry ගොඩාක් පාවිච්චි කරන්නේ single screw extruders. Why we have to use high temperature and high shear to develop expanded food products. You know, for many extruded food products, when we consider about extruded food products, so expanded food products are most popular among the society, among the people. So therefore, mostly we are using single screw extruders. Initial cost is almost double than single screw extruders. Based on the screw types and rotating style, there are 2 major types and 4 subclasses. Right? එතකොට මෙතන screws දෙකක් තියෙනවා. එතකොට conical parallel වෙන්න පුළුවන්, counter rotating, co-rotating වෙන්න පුළුවන්, non intermeshing වෙන්න පුළුවන්. So there are different types of twin screw extruders. හරිද? එතකොට co-rotating, counter rotating කියන්නේ screw දෙකම එක පැත්තට කරකිනවා නම් we call it as co-rotating. screw දෙක දෙපැත්තට කරකිනවා නම් it is a counter rotating extruder. හරිද? So intermeshing කියන්නේ මේ දෙක එකිනෙකට සම්බන්ධ වෙලා වගේ මේ එතන ඔයගොල්ලෝ පේනවා in this first picture you can see two barrels, two screws, how they have installed. එතන මේ දෙක එකිනෙක එකක් ඇතුළට එකක් යන විදියට intermeshing විදියට තමයි හදලා තියෙන්නේ. So non intermeshing කියන්නේ ඒ වගේ වෙලා නැති එක. Right? Then twin screw extruders, you can divide non-intermeshing and intermeshing, and counter rotating and co-rotating, and parallel screws and conical screws. If it is a non-intermeshing one, there are counter rotating and co-rotating screws. Right? This is a classification. Right? You have to remember the changes, the differences in between single screw and twin screw. Right? And how to do the classification, right? And the temperature differences, pressure differences, barrel surface differences, right? All these things are very important. Do not try to remember, but practically you can understand, and then you will have a very good knowledge. You can see intermeshing co-rotating extruders to have the same hand. Intermeshing කරන මෙන්න මේක ඇතුළට ගිරිලා තියෙන එකක් මේකෙත් එහෙමයි intermeshing counter rotating. Here you can see non intermeshing counter rotating, right? Non intermeshing ඒ දෙක සම්බන්ධ නැහැ. Counter rotating කියන්නේ විරුද්ධ පැති වලට කරකේ. Right? Here also you can see some pictures and examples. So I hope that you can easily understand the differences in between these two. Right? Intermeshing screws result in greater residence time of the material inside the extruder. Meanwhile, non-intermeshing screws cause greater degree of shear. Specifically, they rotate opposite sides. So, the residence time means if food if it is a non-intermeshing, the residence time is higher. Residence time is greater than non-intermeshing. If it is a non-intermeshing, then shear is high, right? Shear is high. So, එතකොට අපිට අදාළ application එක අනුව අපි ඒක select කරගන්න ඕන. Right? Then intermeshing screws are more effective and increasing the drag flow while reducing slipping of the materials inside it. Intermeshing extruders වල drag flow එක වැඩි, ඒ වගේම slipping අඩුයි. Slipping අඩුයි කියන්නේ pressure flow එක, backward flow එක අඩු වෙනවා automatically. Right? එතකොට intermeshing flow වල drag flow එක වැඩි, right? And non-intermeshing screws provide higher shear than intermeshing extruders due to its open channel in between two screws. Right? The screw දෙක අතර තියෙන open area එකක්. ඒක නිසා ඒකේ shear එක වැඩි. Right? එතකොට twin screw extruders ගත්තාම එතන zones හතරක් තියෙනවා. There are 4 major zones in twin screw extruders such as mixing, cooking, depressurizing and forming. So numbers should be corrected 1, 2, 3, 4. Mixing, cooking, depressurizing and forming. There are four major reasons, major areas in twin screw extruders. Right? Hope those things are clear. ඔයගොල්ලෝ මේක තේරුණා කියලා මම හිතනවා. මේක දේවල්දී ලොකු දේවල් නෙවෙයි, මතක තියාගන්න පුළුවන්, තේරුම් ගන්න පුළුවන්. Mixing zone එකක් තියෙනවා. Mixing zone එකේ screw channel depth එක large. Large screw channel depth. ඔයගොල්ලෝ දැන් ඔළුවේ මවා ගන්න ඕන screw channel depth එක කියන්නේ මොකක්ද? ඒක වැඩි. Reverse threaded screws for longer residence time. Reverse threaded screws. ඒ කියන්නේ screws අනිත් පැත්තට හදපු flights උත් තියෙනවා. මොකටද? residence time එක වැඩි කරගන්න. ඒ කියන්නේ අපිට cooking කරගන්න ගොඩක් වෙලා මේ food එක ඇතුලේ තියාගන්න අවශ්‍ය නම් තමයි අපිට residence time එක වැඩි කරගන්න ඕනේ. ඒතර cooking zone එක, when it comes to cooking zone, increase the root diameter here. Root diameter has been increased. It means low channel depth නේද? දැන් මුලින් කරේ screw channel depth එක වැඩි කරගත්ත mixing zone එකේ. මෙතනදී කරලා තියෙන්නේ ඒක අඩු කරා. ඒ වෙනුවට අපි වැඩි කරනවා root diameter. එතකොට ඔයගොල්ලෝ දන්නවා by experience what happened to the pressure and output. Depth to provide material for cooking and increase the pressure. Pressure එක වැඩි වෙනවා ඔයගොල්ලෝ දන්නවා. Depressurizing zone, third zone. Here again small root diameter, deeper channel depth and low pressure. So all these three factors are very important. කොහොමද අපි බලන්න ඔයගොල්ලෝ එකම extrude එක ඇතුලේ කොහොමද අපි pressure එක temperature එක වෙනස් කරගන්නේ? Retention time එක වෙනස් කරගන්නේ. දැන් ඔයගොල්ලෝ දන්නවා මේ පැත්තෙන් raw food දැම්මාම when we feed from left side, from the right side you can collect the food output. So we have to maintain, we have to adjust the time and the pressure. All these factors we have to adjust. But barrel is inside the unique barrel, particular barrel, there are different zones. So based on our requirement and the pressure, time, as an example, pressure, retention time and shear, so we can change these factors and designs. So different fabrications. So mixing zone එකයි cooking zone එකයි depressurization zone එක ගත්තොත් මේක ගොඩක් වෙනස්කම් තියෙනවා. So පළවෙනි එකේ screw channel depth එක වැඩි. එතකොට root diameter එක අඩුයි. Reverse threaded screws තියෙනවා. ඒතර වගේ ඇයි අපි ඒ පාවිච්චි කරන්නේ? So depressurization zone එකට ගියාම අපිට ඕනේ pressure එක අඩු කරගන්න. එතකොට අපි කරන්න ඕන channel depth එක අඩු කරගන්න ඕන. Sorry, channel depth එක වැඩි කරන්න screw diameter එක අඩු කරගන්න. හරි? එතකොට අන්න ඒව ඔයගොල්ලෝ අනිවාර්යයෙන්ම දැනගෙන තියාගන්න. එතකොට forming section increase root diameter, reduce channel depth, high pressure applied on food material. එතකොට අන්තිම zone එකට ගියාම අපි die එක තියෙන හරියේදී ඔයගොල්ලෝ දන්නවා pressure එක ඉතාම වැඩි. එතකොට එතෙන්දි තමයි food එක form වෙලා එන්නේ product එක. Right? So there are different zones in twin screw extruders. Right? එතකොට single screw extruder වඩා ගොඩාක් වෙනස් twin screw extruder එක. Do you have any questions? Then we have few minutes, so we can start the next one also. Right now we can start the fifth one. So we have discussed the operating diagram, basic design, classifications also, and solid flow rate calculation and twin screw extruder. So අපි ඒතකොට මේ දේවල් අද කතා කරා කොහොමද එකින් එක වෙනස් වෙන්නේ කියලා. Right? So අපි factors කීපයයි කතා කරේ. channel depth එක, root diameter එක, pressure එක, shear එක, groove, whether it is a grooved or not. And if it is a grooved one, so there are different grooving methods, grooving designs. So we have discussed the importance of all these factors and some examples, real-time examples, some available in the product, food products available in the market. So if it is a pasta, might be a chip like expanded food product. So which type of extruder we have to select. Right? එතකොට ඔයගොල්ලෝ noodle එකක් හදන්න යනවා නම් pasta එකක් හදන්න යනවා නම් high pressure, high temperature එකක් ගත්තොත් මොකද වෙන්නේ? Right? High temperature එකක් ගත්තොත් මොකද වෙන්නේ? එතකොට අපිට ඒකේ proper shape එක ගන්න බෑ. Right? එතකොට shallow flight depths අපි ගත්තොත් මොකද වෙන්නේ? අපි grooved barrel එකක් ගත්තේ නැත්නම් අපි TPT හදන්න ගත්ත high pressure එකක මොකද වෙන්නේ? right? Flow rate එක වැඩි කරගන්න නම් අපි මොකද්ද කරන්න ඕන? මේ දේවල් ඉතාම වැදගත් සහ basic දේවල්. ඒක නිසා highlight කරලා මතක තියාගන්න. In your paper also, as I told you always, you have to have a good understanding on those factors, right? So අපි ඒ කතා ටික අද ඉවර කරනවා. අතට ඔයගොල්ලෝ දන්නවා twin screw extruders ගැන අපි ගොඩක් දුරට කතා කරන්න යන්නේ නැහැ. Single screw, twin screw අතර තියෙන ප්‍රධාන වෙනස්කම් කීපයක් තියෙනවා. එකක් screw දෙකක් තියෙනවා ප්‍රධානම එක. ඒතර ඒ screw වල තියෙන shape එක පිහිටීම කොහොමද අනුව whether it is a intermeshing or non-intermeshing and counter rotating or port rotating. එක පැත්තටම කරගෙනවද විරුද්ධ පැති වලට කරගෙනවද කියන වෙනස. And the retention time also different and shear also different, and especially the force and the techniques used in those two extruders are totally different, right? So I hope that you all have very good knowledge. Then we are moving to the other part, die forming, the last part. It means the last part of the extruder. Then අපි extruder එකේ කතා කරනකොට die එක තමයි අන්තිමටම තියෙන්නේ. So die forming means passing a melted stuff through a specifically designed die opening under high pressure due to pressure difference between inside and outside. ඉතින් අපි extrusion, what is extrusion කියලා අහුවාම දෙන උත්තරයක් තිබුණා. The first day we have discussed what is extrusion. Extrusion means in this definition there is a pressure difference. There is a pressure difference in inside and outside. So we have to use an screw, right? Then we pass some raw materials, melted raw materials through this die to get a particular shape. That is actually extrusion, no? So diforming කියන්නේ ඒකම තමයි ඇත්තටම අපි මෙතන molten solution කියන්නේ ඔයගොල්ලෝ දන්නවා අපි raw materials use කරන දැන් flour water flavors ඒව use කරලා ටිකක් රත් වෙනකොට මේවා melt වෙනවා melt වෙලා අර හැදෙනවා molten solution එක. As an example, when you mix sugar and water together and boil it up to some temperature, it's around 100 degrees or 80 to 100, then you can get a molten solution. Okay? Pressure drop, temperature changes, viscosity difference, and changes of the flow rate might occur during diforming. So, in diforming, you can, all these factors are changing. Diconductance factor is very important. So diconductance factor කියන්නේ it is a unique factor, unique measurement for a particular extruder. Diconductance factor එක වැදගත් වෙනවා. It is depend on die resistance factor. resistance එක අනුව අනිවාර්යයෙන්ම conductance එක හොඳා පවතිනවා. ඒතර කොච්චර ප්‍රතිරෝධයක් තියෙද කියලා බලනවා. ඒක තුලින් යන්න පුළුවන් නම් නේද? resistance එක වැඩි නම් conductance factor එක අනිවාර්යයෙන්ම අඩු වෙනවා. Right? පිට තියෙන ප්‍රතිවිරෝධය වැඩි නම් එතනින් යන ප්‍රමාණය අඩු වෙනවා. So if it is a extruder with high die resistance, so probably the die conductance factor should be a lower one. Right? Die texture is also very important. Typically we use Teflon like hard materials in developing dies. die එක හදන්න අපි කතා කරා ගොඩක් hard materials අපි use කරනවා. මොකද pressure එක ගොඩක් වැඩි. ඒක නිසා අපිට use කරන්න වෙනවා hard material එක. සාමාන්‍යයෙන් අපි Teflon වගේ දෙයක් තමයි use කරන්නේ, right? So in most extruder, the extrude date is getting swollen after the process called dry, right? Right? එතකොට අපි දන්නවා most extruders වල extrude date එක getting swollen, right? ඉදි වෙනවා. පරිමාව වැඩි වෙනවා, right? So usually extruded expansion occurs as a result of high temperature, low moisture extrusion cooking. Right? එතකොට extruded food product එකක් කියන්නේ අපි expand වෙනව නම් ඒක අනිවාර්යයෙන්ම ඒකට අපිට use කරන්න වෙන්නේ low moisture content එකක්. අපි මේ කතා කරනවා පස්සේ. So if it is a high if it is expanded food products such as a TPT, we have to use high temperature but low moisture content, right? It is a consequence of several factors such as biopolymer structural transformations, phase transitions, nucleation, extruded swell, bubble growth, bubble collapse, and bubble dynamics. We will discuss all these terms in the next few lectures. So suppose you have very good knowledge on the extrusion now. So I'm going to stop now. So we will start with this slide in next week. So it's time for your questions now. And while you're asking questions, so I will summarize the things we have discussed, right? එතකොට දැන් ඔයගොල්ලෝ ප්‍රශ්න දින අහන්න නැත්නම් ටෙක්ස්ට් එකක් දාන්න මේකට. ඒ අතරේ මම සමරයිස් කරන්නම් මොනවද අපි කතා කරේ කියලාද. සහ ඔයගොල්ලෝ කරන්න තියෙන දේවල්. අද අපි මේ පැය සතරම් මේක පැය දෙකක් කර ලෙක්චර් එකක් ෆිසිකලි කරොත් මේ ඔන්ලයින් ඕගොල්ලන්ට බෝරින් නිසා තමයි මම මේ පැයකින් ඉවර කරන්නේ. right? If I have a chance to meet you physically, then we can discuss more and we can draw diagrams, we can discuss with actual samples. So unfortunately still we don't have that opportunity. So hopefully we will have a chance. So එතකොට අපි දැන් මේක important part ටික අද කතා කරා. ඔයගොල්ලන්ට exercises දුන්න ගෙදරදී. එතකොට ඔයගොල්ලෝ time you have to use that time and do those exercises. Right? If we can meet together physically, then we can discuss those things in the class. But unfortunately, you have to do these things in your home, right? එතකොට අපි එද කතා කර දේවල් ගොඩක් මතක තියාගන්න විශේෂයෙන් parameters ඒ දේවල් නැතුව අපිට ඉස්සරහට යන්න බෑ. ඉස්සරහ lectures වලට යන්න අමාරුයි. ඒ නිසා the parameters we have used and the effect of those parameters, all these things are very important in extrusion, and also the design and the fabrication. So all these things are important. Hope you don't have any questions. So I'm so happy that you all have understood well. Thank you very much. And if you have any questions, please contact me.
සර්
Yes.
මේ අර assignment එකට එන්න ඕනි මොනවද කියලා විස්තරයක් දෙනවා කිව්වා නේද සර්?
Mama, I will share a PDF document with regarding the things you have to incorporate in those assignments. Don't worry, I will share that. So let's. So you will have another lecture in 12:30. So it's time to stop. So let's meet in the next week. So thank you very much for your patience and participation.
Thank you.
Thank you, sir.
Thank you.